No flicker. We're good. We're good to go. So, as I said, we're just analyzing graphs today. And the idea of analyzing graphs is if we're going to graph them, we should know what all of this stuff means that we're looking at in the graphs. There's a lot of things that you can tell just by looking at a graph. I'm going to move me to the other side of the thing so that I can actually scroll on the screen here and see if I actually got to the bottom. This is just a picture of a city that has nothing to do with what we're doing today. So the graph of a function f is the collection of ordered pairs. The graph of anything that we do usually is a collection of ordered pairs. It's just sometimes it makes a line, sometimes it makes a squiggly line, sometimes it makes a circle, right? But they're all ordered pairs anytime we have a graph because it's just any point creates an ordered pair. And if you look at it, you can notice that x is the distance away from the y axis, right? Any x number we have is just measuring a distance away from y in either direction, just like any y value is measuring a distance away from x in any direction, right? So when we're talking about the domain and range of a function, this can't be the first time you guys have heard about domain and range. Does anybody remember what a domain is? I'm giving a little time because you heard about it in Algebra 1. They hammered it in Algebra 2, but Algebra 2 was weird for you guys because it was all COVID time. Excellent. Nobody knows. That's good. It gives me the chance to express my knowledge on the situation.
Wait, what?
I'm going to totally flex on you now as I define domain and range of a function. I was asking if anybody knew what the domain of a function was.
Would you mind if I slightly move this table this way?
Do what you got to do to plug that computer in. The domain of a function.
Put it into another computer if you have to.
The domain of a function is all of your possible inputs into that function, your x values. Anything that I can put in as an x on here would be my domain. Anything that y can be, all of my potential y values are my range. They're the output. So the domain is your input, your x's. The range is all of your possible outputs, your y's, right? And if we look at this graph right here, our domain runs from -1 all the way to 5, right? If I was going to write it in terms of an interval, it would include -1 and it wouldn't include 5, right? So it would look like if I was going to try and write with the eraser. So it would include -1. So we would have bracket -1 because it's including it. And it would go all the way to 5, but 5's an open dot. So we don't include 5. It gets a parentheses. Do you guys remember that for writing notation? Bracket means you're including it. Parentheses means you're not including it, but you're going up to it. Sort of like with the open dot and the closed dot when you graph them. If we want to look at the range on this, what is my range? My range is going to run from -3 all the way to its highest point at 0. It's including that -3. It's got a solid dot, and it's including that 0. So if this is my domain, right, my range are all of the potential y values. So it's going to start at 0 and end at -3. Technically, we would write it as it starts at -3 because you go lowest to highest, and it will go all the way up to 0. It is including both. They're all solid dots. There's no open dots on there. Oops, but I still made it a parentheses instead of a bracket. So when you're analyzing a function, just looking at a graph, everything's visible. You don't have to do anything algebraically to understand how it works, right? You can just look at the graph and see. What if I had a graph that looked like, it's hard to draw on this thing like that. What if my graph kind of went, we'll start at 0 here. We'll do a little parabola. If I'm looking at the domain of this function, right, this parabola that I drew, pretend that it's even on both sides. I know I'm not perfect. I'm close, but I'm not perfect. If I want the domain of this function, if you notice, I have an x value that's going all the way to the left and all the way to the right, right? My arrows go in both directions. I know they look like they're pointing up, but they're also getting wider going like that, right? They go on forever and ever. My x values can be anything in this circumstance because I got those arrows. They go on for infinity. So my domain on this one is going to be negative infinity to positive infinity, right? It's going to go on forever. What would my range be? I'm going to wait until someone answers in there. I can wait all day. Actually, I can't. I got another class after this one, but I can wait a little while. What would the range be, do you think? I was going to say there's no wrong answers, but there's absolutely wrong answers. You're just not penalized for wrong answers.
Yeah, it was the same.
Yeah. Anybody know what the range is? It is definitely something. You are on the right track there, Nick.
You start with a 0.
Yeah.
It does?
Yeah.
That's good.
That's really good. Did you guys hear that? He said, does it start with a 0? Well, think about this. Our domain is kind of our left to right, correct? So our x values, it's our left to right. And we know it goes both directions, left to right. Our range is our up and down. Does it go down?
No, I have a question. So wouldn't it, because I don't have numbers here, wouldn't it be like 0, like positive, like 3 or 5? Whatever the number is.
Well, notice it's going up forever on
So
both
0
sides.
Infinity?
0 to infinity.
Okay.
Right? It crosses that 0. That's why the numbers don't matter on this one because it never ends.
Yeah.
Right? But if you look at it, it's going up in both directions, right? Never goes below 0. Right? So we can say that our range starts at 0. It includes 0. And if you notice, both sides go up forever. They've got the arrow. The arrow means forever and ever. Right? So it's going to go to infinity. And you can kind of look at that. Notice I have a parentheses on infinity because it can never equal infinity. Right? So if you have a parentheses or a negative, if you have an infinity or negative infinity, that side will always have a parentheses. But you kind of get the picture in terms of domain and range. Domain, what's happening left to right? Right? What am I allowed to use left to right? I have arrows going in both directions. I can use everything, all real numbers, right? Negative infinity to infinity. My range is what's happening on the up and down, right? So if I've got something like this where it's going on forever here and it's going on forever there, we're good. If I have something like this, if I did like a cube, let's see if I could do this, where I graph something like this and it goes on forever. In that case, it would be negative infinity to infinity, right?
Yeah, because it's going down and up.
Up and down, yeah. And it's still left and right, although it doesn't look it. It looks like it's just it's slightly increasing a little bit as you go every single
I have a
time.
question, just because I remember someone last year. Are we gonna use imaginary numbers this year? Or?
We don't get into a lot of imaginary numbers in pre-calc. Yeah, because we have to use up so much time on trigonometry.
Last year, me and Andrew were sitting there for hours doing those.
I don't think imaginary numbers are all that bad.
No, it's the fact that me and Andrew are this thing called stupid. So it took us a while.
You guys aren't stupid. Or you're not like super stupid.
We're kind of slow sometimes.
I'm trying to remember how to erase that. So domain of this function, if we looked at it, the domain on this one is, let's look at the answer. All real numbers except -3. Why would it be all real numbers except -3? See that open dot right there? At -3,6, it means we are not including that number, right? It hits everywhere but that number. Who knows? It could be like some kind of a fraction where there's an x in the denominator, like that would -3 would make that 0. There's a reason for it. I don't know what the reason is. But if I look at this graph, that open dot automatically tells me that I can't include -3 in the domain. In the range, we have that same issue, right? The range can be starting up here at 3, right? Well, technically it's starting at -infinity, but it's not going to take that -3 either, right? Or would this be, sorry, -6, where this point is, because there's no point here at this -6. But look, there is one here at -6. So there is a point at -6, right? And so the range can be -0 to -infinity, or -infinity to 0, because you go lowest to highest, right? And if we click on this one, it should say -infinity to 3. Why is that? Oh, duh. Because it stops right there. I think I even said earlier when we first looked at it that it only goes up to 3.
That was it. Well, that was fun.
Wasn't that fun?
That was fun.
That's super fun.
Well, everyone, you guys are free to go.
No. We got a lot more to do. Does anybody remember what the vertical line test is? Before I scroll down and tell you what the vertical line test is, I would love to see if anybody knows it.
Put like a vertical line in to test something, right?
Hmm?
I know it.
You're close. There's more to it, though. What are you testing? He says you put in a vertical line to test something. Do you remember what a vertical line test tests?
Did we ever do that last year?
Yeah.
We did?
Yeah.
I wasn't paying attention.
Come on, work with me, people. Don't make it a conversation.
What was it?
What does a vertical line test test?
Itself.
No. Nobody knows? Is anybody still here?
Okay, wait.
It's okay if you don't remember.
Someone said ring.
I just wanted to know that I wasn't talking to just kind of Jameson. These two.
If I don't respond, there's a problem.
Yeah, I'll smack you.
You
I can
don't
actually
get it.
get up and just go hit you. I don't even hit my own kids, but I'll hit Jameson.
Okay, isn't it to represent a function?
Did you look that
I
up?
did.
Yeah.
I use my resources.
I'm okay with that. A vertical line test will determine whether or not the graph is a function, right? Basically, the vertical line test says if I drop a vertical line anywhere on the graph of something and it crosses in more than one place, it's not a function. The thing is, I don't know if you remember this about functions, but one of the rules of functions is every x value can only have one y value, right? So if I drop a line anywhere in here and it hits at more than one spot, right? Like here, it hits right here and it hits right here. If it hits at more than one spot, it's saying that this X value has a Y value at -1 and a Y value at, I don't know, about 2.5, right? And every X value can only have one Y value in a function. So if it crosses at more than one point, when I drop a vertical line down into it, it's not a function. And that's the only piece of information you need when you look at it, is if I drop a vertical line anywhere here, right, and it hits more than one point, it's not a function. So A clearly is not a function. This graph is clearly not a function because it crosses here and it crosses here, right? What about this graph, B? Is this a function? Yeah, right? Because anywhere I drop a vertical line, boom, it's only ever going to cross at one point. So that is our function right there. How about C? C is a little tricky. I probably should scroll down so that you can't see the answer to that.
It's no.
Can't you? You could read right there that it's yes.
It's correct, right?
Yeah, it's a function. Even though there's a gap in there where there's no X or Y values, right? Still anywhere on the graph, if I dropped a vertical line, it's only going to cross at one point. So yes, it is a function. I like Isabella there because she covered all her bases in her answer. Yes, no, and oh, oops. Like it's all of them. I love that.
So is this going to be our homework?
Well, sort of. It's about to get a little bit harder.
Why do you have why?
Well, because, I like to torture you. But some of them, literally like 4 problems are going to be a graph.
Don't we have 13 though?
And based on the vertical line test, is it a function? A couple of them are going to look at it and go, well, what's the domain and what's the range by looking at this graph? And you have to be able to write the interval.
Oh, that's not nice.
The next part, let's see, let me make sure I scrolled through this whole deal here that I'm not missing anything. This one's just a test. Let's get the Freddy Krueger marks off of there.
Go from easy, like pretty basic, to just we don't know.
Yeah, pretty much. We're gonna make it hard.
So
there's one tiny part where you have to actually physically do some math.
Dude, math is not my strong suit.
I know, but this is pre-calculus. There's no getting around it. Is this a function?
Math
Is this a function? Look at the picture. Stop talking and look at the picture. Is this a function? I'm getting some yeses. Anybody think it's no?
If you're getting some yeses, I say no.
You're going to say no?
I'm going to say no.
He's going to be wrong. All you yeses are going to be right.
Hey, it's better to stand out.
Because
especially when you're the wrong answer.
Because anywhere you drop a vertical line into that, it's only going to cross at one point. This is the easiest we'll ever have it in pre-calculus, right? Is the vertical line test. I mean, it's a test. Like, if I drop a straight line and is it going to cross at more than one point?
It's just all downhill from here, basically.
This is a weird class today because it's like we're having this conversation while there's a class going on. I know.
It's crazy.
So it's literally that easy, the vertical line test, to determine whether or not something's a function. So on to the next. This is the part where you're going to have to do some actual math. The zeros of a function in quadratics back in Algebra 2 and Algebra 1, we called it the solutions, right? They're always that point on the x-axis, right? Wherever it crosses the x-axis is the zero of a function, right? Think about this. If I have a graph, got to put my pen back on. If I have a graph,
You have a graph.
woo, there's my graph. Right?
Dude, it gets real
There's
weird
my graph.
now.
This is
When
why.
You get that screen, I think you're looking at me and you want like an answer. It becomes awkward. I'm like, you have a graph.
So say I have, let's do a parabola again, right? Just because I like them. It's kind of offset. My zeros are going to be these points where the graph crosses the x-axis, right? Those are my zeros. What is 0?
0? Wouldn't that be that bottom, like that dip?
Well, no,
X.
that's your max and min, which we're going to get into later this week.
Ooh, I'm big brain, not thinking about anything.
What if I was writing this as a point? My x value would be something. Let's call it A. What would my y value be when I wrote this point that's on the x-axis? Well, this is just an A. It could be anything.
Okay.
Right? What would my y value be on this line?
It would be at the second point.
What is y value on the line, the x-axis?
There's no numbers.
It doesn't need a number. It's the x-axis. Look at the answers that the smart people in your class are giving you. Yeah, it's 0, right? You're not going up. Remember in the beginning of this class.
Okay.
Negative 0.
I don't have my thing side, so I can't see the comments.
Remember this. The first thing I said in here is I showed you the graph and I showed you that your x values are your distance away from y, right? In either direction. Your y values are your distance away from x in either direction. So if something sits on that x-axis, it's no distance away from it. It's just 0.
Okay, that makes sense. I just wasn't paying attention.
Okay, but now you need to be quiet. So my point would be whatever number this is, and then 0, right? So when we're looking for the zeros of a function, we just make our y 0, right? So if I have f of x or y, right, because f of x and y are interchangeable, equals x plus 2, and I want to find the zeros of that, I would just set x plus 2 equal to 0, and then I would solve for x. Does that make some sense?
Yeah, sure.
Because it's x when y is 0.
Yeah.
So I would just subtract 2 from both sides. Now this is pretty basic, right? And I would get x equals negative 2.
Not for him.
Now we have x.
Right? But that's our zeros. When we solve for x, what we're actually trying to figure out is where does the graph of this cross the x-axis? Right? There are x-intercepts, we call them roots, we call them solutions, we call them the zeros. They have a lot of names. But ultimately, it means we're going to set this function equal to 0. Because when y is 0, we want to know what x is. Make some sense? I hope so. Let's look at this problem. It's all solved out for us. We got 3 problems right here. We have 3x squared plus x minus 10, right? The way they do it is they factor this problem. And it's an easy factor if you remember how to factor when they set it equal to 0, right? 3x squared plus x minus 10. I don't know how you do your factoring, but if you don't know how to factor it, remember the quadratic formula, because the quadratic formula always works. But when I look at 3x plus 10 and I want to factor it, I have a little method that I use. I don't know if you guys know this one, but if I do 3x plus x minus 10 equals 0, and I want to factor this out to figure out what my factors are, because if I make this factor 0 or this factor 0, the whole thing becomes 0, because multiplication, zero product property. When I do it, I multiply these two right here, and I would rewrite this as x plus x squared. Forgot my little square. That would have messed everything up. Minus 30, right? Now I'm going to find the factors of negative 30 that equal x, right? So I would go, I know it's going to be positive, so my smaller one is going to be the negative. So I'd go 1 and 30, and then I'd have negative 2 and 15, and negative 3 and 10, until I get to negative 5 and 6. Right? Because when I add these two together, they give me 1, so I know it works. So I,
question, but why negative 5 and 6?
Because 5 times 6 equals 30.
Oh. My brain's
That's
not
that's
working.
what factors are.
Yeah, I was
Yeah.
thinking, I was like, this looks like I know what this is. But
So I could write this now as x plus 6 times, times x minus 5, right? And all those are equal to 0. But I have to put that 3 back in that I took out. So when I do that, I'm going to just divide this by 3 and this side by 3. And I'm going to look at these factors and I'm going to go, well, 6 divided by 3 is just 2. So this becomes x plus 2. 5 divided by 3 is not a good number, right? It doesn't divide evenly. So I'm going to take this 3 and put it in front of the x. And I wind up with 3x minus 5 equals 0, right? And now I can set each of those factors equal to 0 to find out what my zeros are, right? Because if this unit right here equals 0, when I multiply it times this, the whole thing becomes 0. And if this grouping right here equals 0 and I multiply it times this, the whole thing becomes 0. So we're just going to solve each of these. 3x minus 5 equals 0 gives us x equals 5/3. And then x plus 2 equals 0 gives us x minus 2. And so these are the zeros of this function. Does that make some sense? I hope I explained that well. Usually I do all this while I'm writing it. And so it's weird to have these problems already solved out. Because
I'm gonna be honest. I don't know how I'm in pre-calc.
you signed up for it.
I didn't sign up for anything.
Well, someone signed you up for it.
Someone definitely did.
That's what happens when you get a good grade in Algebra 2.
Well,
and you can see right here on the graph of this function, right? These are my zeros.
This is what happens when you're born.
Our next one, we're looking at the square root of 10 minus x squared equals 0. Anytime you have a square root, square both sides, right? It gets rid of the square root and you're left with whatever is underneath it. Conveniently, one of the sides we're squaring is a 0, and 0 times 0 is just 0, right? So it doesn't change anything. And then we're just going to solve this for our x, right? And if you look at this, they kind of do that with you, right? They move the x squared over to get rid of the negative. So all they did was add x squared to both sides so that you're left with 10 equals x squared. And then to find out what x is, you're just going to take the square root of both sides. It doesn't break down evenly. So it's just plus or minus the square root of 10. But keep in mind, it's plus or minus the square root of 10. That's two separate solutions for those zeros. One is minus the square root of 10, which is probably like a little over 3, right? Negative 3. And the other one is the positive side of the square root over 10, which is like a little over positive 3. Does that make some sense? And you can see it right there, right? Little semicircle. The last function that they give us to find the zeros of is a fraction. And I believe that they did that for one reason. And that is that you got to remember that you can't have a 0 in the denominator of a fraction. So there's certain things that it can't be. They got rid of the fraction right off the bat, right? When they were solving it, they multiply both sides by t plus f. I mean, t plus 5. I don't know why I said f, except for that 5 starts with that letter, right? And it clears the fraction, right? You guys remember that, don't you? If you multiply something by the denominator, it clears out the denominator. You have to do it on both sides, but the other side is just 0, right? If I have to turn my pen on, if I have 2t minus 3 over t plus 5 equals 0, and I multiply both sides by t plus 5, right? T plus 5. What happens here? This cancels, right? And I'm left with 2t minus 3. You can read that. Equals, well, what's 0 times t plus 5? It's just 0. So all we have to do is solve this for t, right? And we'll know the 0 of that function, right? And that just means getting that t by itself. So I'd add 3 and add 3, and I'd get 2t equals 3. And then we could divide out the 2, and we get t equals 3 halves. Does that make some sense? I feel like I say that a lot. Does that make some sense? I'm not going to make you do the checkpoint. You'll have plenty of checkpoints on your own to do. The last thing that we're going to go over is increasing and decreasing functions. And it's literally just that. You're going to look at the graph and determine where it's increasing and where it's decreasing, right? And you're going to write the intervals. That will be the hardest part. Forget this stuff right here. Look at this graph. From -2 to 0, it's going down. It's decreasing. If I'm going to write that where it's decreasing, right? If it asks me where it's decreasing, which it will, decreasing, I am going to write the interval. Solid dot. So it gets a bracket, not a parentheses. -2. Where does it go to? Well, it goes to 0. It includes that 0, so that's also getting a bracket. It is a constant, right? From 0 to 2. Also bracket. Bracket. It increases from 2 to, what is that, 4? All solid dots, so they all get brackets. That's literally all there is to it.
That's it.
Right? The only thing that could be different, if one of these was an open dot, it'd get a parentheses where you start, right? Because it's not including it, it's going up to it. But that's literally it. You're going to look at the graphs and you're going to determine where it's decreasing, where it's constant, a straight line, and where it's increasing, and you're going to write those intervals, right? Like I said, this isn't super hard stuff today because it's all about understanding and being able to read the graphs. So let's look at one right here. Let's look at this, and we're going to describe the behaviors of these functions. And we're going to try not to look at the solutions down here, right? Let's see if I'm gonna scroll down. That's what I'm going to do. I'm going to look at this, and I'm going to go from here. We're going like -infinity, right? I don't know how far over this is going to go. The function is increasing on the interval from -infinity to -1, right? We're just assuming these are going on forever at the end, right? It's including that -1. From -1 to 1, it's decreasing, right? And then from 1 to infinity, it's increasing, right? Not too difficult, right? Here we're increasing from infinity to 0. We are constant from 0 to 2. And from 2 to infinity, it's decreasing. Does that make sense? What's happening here? -infinity to 0, it's increasing. And 0 to infinity, it's increasing. The whole thing is going up, right? So you could write from -infinity it's increasing on the interval negative infinity to infinity. That is as far as I'm taking you on this today. When I see you later this week, we're going to go over minimums and maximums and rate of change. But I didn't want to throw all that in today. So, Nick, it's a good time for you to have to go because we've pretty much finished the lesson portion of this. If you guys want, I can take you through a little bit of the assignments to look at them, but this stuff we're not getting to until the second half of this week. But I do want to kind of get you guys out of here a little bit. It's not even a little bit quickly because the bell's going to ring in like a minute, huh? I wanted to walk Isabella through the stuff. So I'm going to kick you guys out. You all are free to go.